Well, hello, and welcome back. Sorry, I didn't give a lot of time to tune in, but it's okay because we have a nice cold Mountain Dew. That's right. Let's see what he has to say. Ah, cheers. Okay, so I had a little bit of trouble. I run a service and it has users. And because I have not yet built the merchant tools, the users are free users. And free users are the worst because, they do illegal stuff that gets you in trouble and whatnot. So I had to spend some time, again, for the second time this month, banning a user's account. And I decided that while I was doing it to automate it a little bit because there's not, I don't have a ban button for the service. And so, oh yeah, this is basically it right here. So if you want this IP address right here, if you want to attack that person, that's the person to attack. Except it may not even be their IP address. They're probably tunneled in through something else. But anyway, so, whoops, there we go. Yeah, it was just somebody doing dumb stuff, So I decided to. I already had a script that kind of did a couple of actions, and I improved it so that it is easier to ban someone. Because, well, and the other thing is I don't actually want to. It's more of a shadow ban because they can still connect. I think they can, actually, maybe they can't. I don't remember. Anyway, it just, yeah, they're banned. The user is banned. That's the thing. All right. But pretty soon here we're going to start to have paid users, and once we have paid users are good users. Paid users don't cause you a lot of trouble. Paid users don't complain as much. Not that I really get that many complaints, but paid users are the people who are satisfied and, generally speaking, want to do good. So we like them. Okay. And I ended up watching 2 episodes of a show with my wife. So here we are 3 hours later. I need to, well, let's see. I might have to go to bed early and come back to this again because it's going to be 2:30, 3:30. Yeah, I can go till 3:30. I can go till 3:30, no problem. I'm not even tired. Okay, so what we are getting to, whoops, is, okay, I wanted to show coins. So here's my dev wallet. And I actually wanted to see what happens if I do more than one of these. I want to see what happens when I do. I think I should still get the same error. Yep. And do I have something small that I can put in here? What happens there? Oh, hey, it works. Cool. Oh, that's great. What happens if I do one more of these 0.2s? What happens if I have 2 of them? Interesting. Oh, they have a bunch of stamps on them. That's how they end up being. So, okay. Gotcha. Okay. Cool. So that looks good. Let's see what happens if we just take this one. And that breaks down into... Ooh. That went down the right pipe. Oh, I forgot to play the music. Let's get the music back on. There we go. And feel free to say hello, chat. This is Final Fantasy V Ancient Waves by Rebecca E. Tripp. Lots of Rebecca E. Tripp showing up the last little bit. Okay, cool. So this is good. So I think that's one down and 3 or 4 to go. Okay, so you select coins. Cache-like transfer of coins. So this one is good. Oh. All right, so the next one is we have... Okay, let's see. Can we... Oh. Okay, maybe it wasn't the right pipe after all. All right. So here... So here we just throw another error. And we've got a similar error already. I gotta go find it. It's probably in the create tx function or create dirty tx. Alright, must select inputs. So if full transfer. Okay. I may just want to put an error here. Just creating an error is sometimes nice to put into its own function, just because it, I don't know, it gives a space. Let's see. Okay, there we go. See, that just makes it feel a little more cozy. Possibly no. Brah! We need like what they have in Ruby where you can get something definitely a Boolean. Anyway. How's it going, chat? Possibly null or undefined. Yeah, or null or undefined. Got it. I wish it knew. We'll just go with that. That's fine. Wait. Oh, if not, there we go. Okay. I really wish that it would transitively understand that if we check this, then we're checking that. Because I like to give things names to make them easier to understand. Because otherwise we gotta put comments, and the comments are inevitably gonna get out of date, yada yada. I guess I could also just change the type information. Let me see, does this even... No, this doesn't work. because this is, if it's nullish, I don't know. So with this, if not utxos.length, or just this. There. Now we know that that must be there. Now I can give things nice names. Okay. So here we are. So if this is a full transfer, then do all these things. And we could possibly pull this out into its own function too. Okay, so we have wallet.select all inputs. And do we need anything else? Alright, there we go. Alright, is there anything else needed here? Cool. Alright, good enough. Okay, so if full transfer, select all inputs. There's the selection. Great. Whoops. Okay, cool. Alright, so that one's done. But now we need to handle the next, which is going to be that we have both. So if let's see. wallet. Okay. So if it doesn't have selected coins, that's where UTXOs are going to be the full wallet. So at this point, it kind of feels like that actually belongs somewhere else, because that would change this to being... Does that belong somewhere else? No. Because otherwise we have the full wallet problem. Okay, so select coins may just need to be asynchronous. Let me think about this for a second. So I'd prefer this not to be asynchronous, but one of two things has to happen. Either I have to have a mechanism to get all the coins from the wallet, or the wallet coins need to be passed in. Bless me. So there might need to be some sort of restructuring of what this should look like. Because basically I want to be able to do all of the bits where we can decide how to select the coins. I mean, maybe what that points to is that this section right here really belongs somewhere else. And that I'm okay with. I can live with that. If we say that this, these 5 lines actually belong elsewhere in the higher level. I could be okay with that. We could call this coin control select. Or maybe instead of calling this UTXOs, it could be called coin control. That could work. Okay, has selected coins. But anyway, my point was right there. That's where I've got to pull it in. Can you ask what I'm building? Yes. Yes, Quant Cran, you can. I am building a Dash digital cash wallet, or rather a library for the wallet. Well, I am also kind of building parts of the wallet itself. But what I have been working on for the past 10 or so sessions has been coin selection, which turns out to be a really difficult problem because these are supposed to be cash-like transactions, because the way that cryptocurrencies work is they all have an unending chain that links every transaction to every other transaction, and this is the problem of dealing with floats rather than integers, essentially, is that when you're dealing with a floating point number, well, it's not really a floating point number, it really is an integer, but when you're dealing with something that has a lot of when you're dealing with non-discrete values, so discrete values would be the way that cash is, 5, 10, 20, etc. When you're dealing with discrete values, then the exchange of money doesn't convey any information about the transfer or the person. It's just money moves and value moves. But with a ledger, every transaction tells some data about the people involved and the nature of the transaction. Because you can link everything to everything else. You can see what the cadence of the transactions is. There's just a lot of information that's out there that you typically wouldn't want. That's typically just not. It's undesirable. I can't think of any situation where where you want to publish information about the way that you do things with money, because there's bad actors out there that want to correlate that information. You see this on YouTube. Often it's done kind of from, in a good way, though. Often it's done, YouTubers will show how scammers have used cryptocurrencies for this, that, or the other. But Dash is not really targeted towards scammers. It's more targeted towards everyday purchases. So I'll bring up the website here. Dash.org. Your money, your way. Make everyday purchases with digital cash. So that's the goal behind Dash. So that's very different from most cryptocurrencies. Anyway, so I'm just working on something that will make the transactions more cash-like and more digital cash and currency-like by the way that it communicates the numbers, so that the numbers are discrete values, just like dollar bills are discrete values, rather than being essentially fingerprinted values. That's what I'm working on. Specifically, what I'm working on right now is the ability to check to see what is actually in the wallet. And where was that at? Must select inputs. Select optimal inputs. Where to get? Wallet.utxos. Yeah. Maybe that could just be passed in when the function's used. I don't know. I have to think about that. Because the problem here is, well, okay, we're just going to go with, there should be a synchronous method by which you can get the coins, and you probably don't have 100,000 coins. You probably have less than 10,000 coins. I mean, let's just think about this real quick. If I had 10,000 times 0.005, that's going to be 50. So, yeah, I probably... It's really, really unlikely that you'd have 10,000 coins and they'd all be super tiny. And if they were super tiny, they're kind of useless. So we'll go with, you have less than 10,000 coins. We're making the assumption that whatever mechanism initializes or loads... Well, I also kind of want to be able to say which accounts... let's see here. So we want to select account, select coins, and we want to say I don't know, account coins? I don't know if this is how I want to do it ultimately, but this is how we're going to do it right now. Alright, I don't know much about cryptocurrencies, but just wrote a 15-page report about detecting cryptojackers, and remember looking at Dash. So, cryptojackers are malware that... is that malware that looks for and finds keys on a system? So, you download a dirty picture, and you open it up to look at it, but instead all your money's gone? Is that what we're talking about? I'm not familiar with the term cryptojackers. So I come from a programming background. So to me, crypto means cryptography. Crypto is a word that has a meaning, and it frustrates me to no end that it's like that. That's not what it means. It does. Crypto mean, well, I mean, I guess you could go a couple of different ways from this, but in tech, crypto means cryptography. It means security. It means that something is, yeah. But I guess if you go further back, crypto means paranormal, or there's lots of things that it could mean. But yeah, anyway, 15 pages sounds like quite a bit of pages. Why would you write so many? Oh. Okay. How could that ever be profitable or useful to crypto mine off of the user's machine? Had an independent study? Okay. Explain to me, how could that be useful? Because it's like you're taking something that needs extreme power and you're putting it on the lowest class devices. You're talking $300 laptops that have Celeron processors, and then you're having to do it in a browser where you're taking a performance hit. So, I mean, just, and then things can only... Maybe it doesn't. Maybe the same rules don't apply to WASM modules, but with most JavaScript, if it's not the active tab, there's severe restrictions on the actual run speed. It's what's the word? Clamped. the runtime will be clamped. And so, I mean, that just seems, it seems like if you had the mental capacity to write the scripts that would do the hashing and report it back, it seems like you could just make more money than what you would ever make off of loading a script on a page that is, but I don't know, maybe computers are a lot faster than I think they are. It just seems like with the ASIC wars and all that, it just seems like that just couldn't be profitable. But tell me more. Okay, so we're going to have account coins here. And then I guess this has actually been simplified quite a bit. What's up, chat? How's it going? Let me tilt the camera down a little bit more. That's the pro look. Have a little bit of your head chopped off. No one who's serious shows their whole head, you know. Now I've got too much of my belly in there, though. Ah, trade-offs, right? Am I right? I guess my belly's down here. It's bigger than it looks, but not as big as I thought it was. Because you don't see my belly up here. That's my boobies. Okay, more like a botnet kind of deal, especially with cross-site scripting. If someone can inject some malware into a really popular website, they can get millions of machines running the algorithm for them. Yeah, WASM allows you to run things near native speed, way better than JS, so it is a real problem. If I remember correctly, from 2018 to 2019, some research estimated over $100 million was made off of cryptojacking schemes. Interesting. That just seems astronomical to me. $100 million? I just can't imagine that, because if you had a botnet with millions of machines, it's just, so there's the Android phone versus the iPhone problem, right? So Android phones have more cores of processors, but they're slower because you're not really doing a lot of tasks on a phone. You're typically doing very few tasks on a phone. So what you actually benefit from is not web scale, but you benefit from vertical scale. And so iPhone has a more tightly integrated processor that's much faster and more performant with fewer cores, but they're more performant cores, so the iPhone is better, right? And when I'm thinking of hijacking millions of computers, I'm thinking, oh, okay, so I've got a server that has, 48 threads that it can run, and it just isn't anywhere near as fast as my MacBook. You know, if I were to compile something on the server versus on my MacBook's going to win every time in the face. And, you know, it's so much faster to have a few good computers than to have many crappy computers. You know, it's availability versus performance. There's some contexts in which availability is really, really nice, but there's some contexts in which performance is critical. And it seems like this hashing thing, it just seems like no matter how many millions of computers that you have, it just seems like it would never add up to anything because you'd be limited to, and maybe WASM's still limited to a single core, right? I mean, I'm just thinking that those kind of websites, you're getting people at the bottom of the barrel, you know? 100 million just seems way too big, but you did the research, not me. I'm just skeptical that hundreds of millions of dollars could be made off of millions of devices that are just super dirt cheap devices. I mean, why wouldn't you just go to the thrift shop and just buy up a bunch of computers and leave them to run on? I don't know, because if you could it seems like you'd need GPU hashing, not CPU hashing. It seems, because the scale, I don't know, but that one seems a far cry to me. But maybe if you were cryptojacking and you were doing something like Dash, where there's not a lot of competition in the space, maybe it could be profitable. But if you were trying to do it with Bitcoin, I can't imagine that would be profitable at all, because the hashes are so complex and they take so much time, and you're competing against, you're competing against AWS GPU nets. I just can't see how you'd ever win, because it's a lottery draw, right? You're making, it's how many trillions of guesses can you make a second, and it's far more than trillions. At least on the Bitcoin network. So that's really interesting. Okay, so then I'm going to say we're going to select the inputs. Then no. Let's see. All right, this is shaping out to be all right. Okay, we're going to have an accounts flag. That's one of the things we're going to add over here. So I'm working on the CLI and the library in separate repositories at this point. So we're going to have our break change. So we're going to have one more of these. Yeah, I get what you're saying. Number could be totally off, but I do remember it was a non-significant number for sure. And I mean, that seems to prove itself, and that if it weren't, because you have to have a certain amount of brain capacity in order to run that scam, right? So if you have that brain capacity, it has to be more worth it to run the scam. Well, more worth it, you'd think, because you have to have the brain capacity. If you have the brain capacity, you imagine that you could do risk assessment. And if you can do risk assessment, then the risk that something goes wrong and you end up at a disadvantage, you'd want the advantage to be much greater. You know, you'd want to say, I can make 10 times more scamming if I don't get caught than if I used my brain power, which is obviously pretty big if I can run this scam, to do something that would make me a fairly lucrative amount of money. Paper was mainly focused on the proof of work that were memory based. Oh, so CPU equals GPU. Oh, okay. Yeah, so laptops and computers would definitely have a higher hash rate than an Android phone. On an iPhone, however, the M1 had been in the iPhone for a couple of years before they came out with the M1. So again, that would have been in the 2018-2019 era. iPhones were outperforming desktop class computers. Crazy thing, only 40% of the malware found were unique, so probably I don't know what that means. Just copied and pasted some other dude's stuff. Yeah, so well when Apple, I don't know if it was before or after Apple announced that they were going to do their own chip in the iPhone, but I was telling people back then, I said Apple is going to, they're going to create a computer out of the phone chip. The phone is going to be the next Apple computer, and then lo and behold, and Apple does stuff for years before they release it to the public. So it's not like they decided one day, oh yeah, let's see what it's like to put this in a computer. They had probably been running it in a computer for several years, something like 3 to 5 years is my guess, before they went public on it. Because you don't just, retool your software a little bit and then release a computer for a new architecture. At least I don't think we're there yet. I don't think we're ever going to get there. Technically, I think that we could, but people just they're not smart enough. Okay. Oh, and back to the point about the iPhone outperforming desktop class computers. There weren't really benchmarks. The thing that cued me in was there was there's not a lot of benchmarks that you can do on both a desktop and a phone, right? Most benchmarking software is designed for the desktop. And I don't think anybody at the time was thinking, hey, we should cross benchmark, create a benchmark suite that runs on a phone. It just doesn't. I don't think that's where most people were at. But so in the web development world, somebody had created a benchmark for testing JavaScript. And what they found is that JavaScript ran faster on an iPhone than it did on a MacBook Pro. And the floating point operations in particular were really, really fast on the phone. And that was, huh? But I remember hearing about that. And I didn't expect Rosetta to work out so well. Because when I don't know why, because they did it for Intel. Well, because they kind of went back, because they were on PowerPC, which I don't know why PowerPC was getting so hot though. That's the thing that I don't understand, because PowerPC, I thought it was supposed to be a really efficient platform. Not just powerful, but efficient. And they went from PowerPC to Intel, and that was pretty smooth. But I think the transition from Intel to ARM was even smoother, and I think part of it is because a lot of the common CPU instructions are so similar. But it's crazy that the emulation of the Intel architecture runs faster on the ARM than it does on the actual Intel architecture for a lot of the things that they've been doing. Okay, so I need to get this account list. So let me go find coin list to UTXOs. And then we're going to basically do the same thing, but with an account list. So what I need to do is I've wanted this behavior for a while, where you can basically what I wanted was to choose accounts that you don't pull from. So I think what I'm going to do is say that there's an account that's either called savings or @savings. And it won't pull from that account. By default, it won't pull from that account. And let's see. Okay, I need to grab something over here. Let's see, two... How do I list the accounts? Maybe I should call it account names. That's the wrong word. How's it going, chat? Okay. So this is highly implementation specific. I would like to get this moved out of the library, but for right now it is what it is. I don't want this to have to be all in memory, although it seems like it kind of should fit. What time zone are you in? 4 a.m. over here? It is 2:28 here. Just a regular stay up later, you know. Okay, so... I don't know if this is going to work the way that I want it to. Okay, that's account balances. info.utxo. Let's see. What is the type? Wallet address has a mini UTXO. How do I convert the... I think I've got a function that converts the wallet UTXO into a full UTXO, and I do want that. Well, if I just look up UTXOs, okay, adder info. Account name. Maybe I should get... I'm trying to think of how to do this from a perspective where... Let's see, I probably do need a get account names. But I'll probably build it on top of this. And then I could move balances to be built on top of this as well. So I want to build this out as though we're going to use asynchronous calls. That lends itself generally towards better architecture, and I think that there are going to be complications that require asynchronous calls, that we can't have everything in RAM all the time. Okay, so... Hmm. Let's see here. Satoshi's. Okay, let me check comments here. Oh, just asking about the time zone. Yeah, we already answered that one. Okay, no new questions. Okay, but feel free to ask questions. Bless me. So I'm a software engineer. I have dealt a lot with high-level cryptography, not low-level cryptography. So I have re-implemented cryptographic libraries to some extent, but not the algorithmic portion, the API portion. But authentication end devices. So I have worked on radar systems, clean room control, home automation. There's been a lot of small kind of device oriented projects that I've worked on personally, and then just general web dev. But I know a lot of the weird stuff and protocol layer stuff, and I just about everything I do is both front end and back end, at least when it comes to JavaScript, but I don't deal with things that are exclusively front end. So I'm very much of the opinion that rather than trying to force people who are bad at something to do it, let people who are good at it do it. And so let the people that are great at CSS do CSS, because we need more people that are great at CSS. And we don't need those people bogged down with error handling and API layer stuff. So I very much don't like things like React that try to force people that otherwise could be great at what they do into being mediocre at something that just isn't their thing. And likewise, I don't want to be bogged down with CSS and whatnot. I want to be able to write great code, and then hopefully, other people could use that great code to do great things. And I don't want to be bogged down with the stuff that I'm not good at. So, but I write code with the intent that the code will also work in the browser. That does become increasingly difficult as the browser frameworks keep getting further and further away from JavaScript and have so many layers of things that make it very difficult to use JavaScript functions and JavaScript libraries inside of their frameworks, because they, kind of have abandoned JavaScript in favor of things like JSX and TypeScript, and a lot of that just doesn't play well with JavaScript. But Svelte is our only hope, because Svelte is actually going back to JavaScript. So here's to hoping for that. Okay, anyway, I've got these accounts here. So I think if I were to re-implement the balances, I could just call the accounts. And then what was this? So I think I actually will go ahead. It has loose whiff. What is this? So I have this ignore whiffs, but obviously I'm not ignoring them. I don't know what this comment was for, but I think the code looked different before, and I changed it at some point and didn't update the comment. Another reason that comments are evil. And so now it says ignore whiffs, but I don't really want to ignore the whiffs, right? I'm just leaving it there because I don't remember what that was a marker for. But it's a marker for something. I would actually want to go through and find all the coins that are too small to be useful. And then pair them up with something else. So, I don't know. Okay, anyway, I now have my accounts function. So what we want to have just UTXOs, face value Satoshis, UTXOs. Okay, so let's go back over here. And so now okay, account names, account name of account names. Well, this is a new one. Or at least one I don't remember hearing recently. Mirror image. See, is this new? January 2020. I'm pretty sure we've been listening to this one. Oh no, this is the strings compilation. Okay. So it's a different set. Cool. What's my end goal for this project? Am I trying to sell it, integrate it into a larger application I'm creating? My goal for this project is for me to be able to use it for my digital cash transactions. I would like it to be implemented. I would like this to serve as a prototype that can be implemented across the digital cash ecosystem. Hold on, what's this music with the voices? I do not want vocal. Go away. Anyway. The ideal for me would be that the algorithms that I've prototyped here get adopted across the entire digital cash ecosystem, so that we can have cash-like transactions that fulfill the promise of basically being anti-cryptocurrency and instead being pro-digital cash. Just to have a more sane default system that behaves the way that cash does. It's kind of difficult to explain because it's so obvious. This is the way that you'd want it. That it's kind of it's hard to explain it without using the words of the enemy, because there are there's a lot of political wordplay, right? So, actually, it's difficult for me to pick an example without stepping on hot coals. But there's a lot of political wordplay and things that should be common sense can be twisted to be presented as though they are strange, right? You have certainly seen this happen over the past few years. And so the way that Bitcoin evolved was directed by big tech, big money, and big government, right? So it's a classic case of tell you one thing and give you something else. Tell people, oh, it's liberation, but then just make it an ideal tool for people to launder money with, right? Which is kind of strange, because on the one hand, for the average person, so if you're an investor, it's an easy way to launder money. But if you are the average person, then it's an easy way to have everything that you spend money on traceable. So it's kind of really weird that it fulfills both ends, because from the investor perspective, a lot of the cryptocurrency stuff is about diversifying. Because if you diversify some of your money and you can show losses, then you can move other money from point A to B without it, without it being recognized as what it is, which in a lot of cases, I'm kind of more of the approach that people should be able to do what they want with their money. But anyway, and I'm off on a tangent. Sorry. Anyway, so my goal is just to provide a reference implementation that serves my needs, that can be used in a browser reference implementation that's also being built, and for these algorithms to get adopted into the digital cash ecosystem so that it can fulfill its promise of being cash-like, being a cash-like digital cash, and having the advantages and disadvantages of cash, as opposed to having the advantages and disadvantages of something that's more like a credit card. Credit card transactions are fingerprinted. Blockchain transactions are typically fingerprinted and very easy to trace because it's all public ledger stuff. Cash-like transactions typically don't reveal a lot of information about the parties that are involved. It's more of it's less of a public type of transaction and more of more of an individual transaction. So, and anyway, a lot of it has to do with the coin selection because, okay, so essentially the current algorithm that is broadly deployed across many cryptocurrencies is that it's going to pick the coin that you have that is of the value that is slightly larger. So it's going to order your coins from smallest to largest and go until it finds the first largest coin that can meet the transaction needs. And then coins have to be completely spent. You can't spend part of a coin. So what you do is you send part of the coin to the, or you split the coin. You have to send the full coin, but you split it, and you send part to the recipient and you send part back to yourself. And in the traditional system, the part that goes back to yourself is always at index 1, and the part that goes to the recipient is always at index 0. And so if you want to look at a person's transactions, all you have to do is follow the index 1s all the way back. And you can see how their money is related. And then you also have information about things like exchange rate and whatnot, because you have a lot of decimal places. So given an approximate time based on block height and based on exchange rate, you can tell more information about, what the person, what specifically the person was doing, maybe even down to the exact dollar amount that they paid in their native currency and things like that. So if you can get rid of the excess information that's basically, or not really get rid of, but if you can not simply just not supply excess information that's not necessary, then you're better off. So sorry, I might have gotten tangenty again. I have strong feelings about this, despite the fact that I am not. Well, I guess the reason that I'm a cryptophobe, that I don't like cryptocurrency in general, is because of all of the mistruths, all of the misinformation about them, and the general lack of utility and the crypto bro attitude. So it's very ironic that I ended up working with Dash Incubator, but my goal is to fulfill on the philosophical promises rather than, like, I call out when there's crypto bro crap in the digital cash community. I will call it out and say, hey, I think this is a nothing burger or whatever. Are there websites that graph all these interactions and exchanges? Yes. Would be interesting to see if there was a single place to do these kinds of lookups. I don't know the intricacies. Yes, absolutely. 100%. Yes, there's all sorts of websites for doing analysis. But one of the documentaries that is interesting to look at. What the heck is this? Get that out of my face. Whoa. Let's see. What was it called? Let me see if I can find the Crypto Island and documentary. Crypto Island documentary. I think it was this one, but hold on a second. I'll see if I can find it. No, not there. Yeah, I think it's the one by Kira TV, but I could be wrong. But in one of these videos, he shows some tools where he's able to trace through and look at a specific individual's transactions and then use side channel information to say it's highly, highly likely that these transactions are the same transaction. And what I mean by side channel information is, for example, that a certain amount of money doesn't move for 9 months. Knowing when money moves is something that's in the blockchains, but it's information that you don't necessarily think about. But knowing the cadence of money moving tells you a lot about money. And an example that I bring up again and again and again and again when we're talking about this is email or just messaging in general. Assume that you have an organization and all of the messages are encrypted. So you can't tell what any of the messages say, but your job is to forensically discover as much as you can about this organization of people. Well, if all you can see are interactions between nodes, you can map out the hierarchy of the organization because you're going to see patterns in the messages. So if something is going to happen, you're going to see a message from a person that you've already been able to identify, or a node that you've already been able to identify as important, and you're going to be able to predict that if a message goes out from this node, that message will be relayed to other nodes. So if a message comes from the CEO to the department heads, it's going to go from department heads to product teams, and from product teams to employees. So you're going to see the proliferation of that message, and then based on when messages come back, you're going to see what kind of relationship people down below have with up above, and you could take the timing information, and so you could determine that if a time loop is much quicker between two nodes and one of those nodes is higher up the chain, then you could establish that perhaps there's a personal relationship, or the nature of the business relationship is a lot stronger or more important, things like that, right? So that's the kind of information that you can use some of these tools to look at transactions to see how things move back and forth, and you can make a lot of inferences where you can't say for certain, but you can have a pretty darn good guess. When the money moves, how much of the money moves. That's what I was saying, is that video that I was talking about, which I don't know where it is now. Let me see if I can scroll back in my history, because I'm pretty sure I shared it in a message over here. Let me see if I can go back. Scrolling really far back in my message history, and I am not finding it. But I don't know what the website is because I don't do that. But yes, websites exist that allow you to cross-reference this information. I mean, there's very, very simple ones. Like the simplest ones are just called block explorers. So if I was going to look for dash block explorer, let's see, there's block share, block cipher, that's a good one, insight. So we could stick in a transaction. So for example, first let me finish this little function. Let's see, what is it complaining about? All right, so if Invalid account names. Alright, known account names. Okay, so there's... And then we can take account names and then for let account name of account names. We can do what? We can do just join all the coins together, right? UTXOs. So let account equals accounts account name. UTXOs equals UTXOs.concat account.UTXOs. And then do we have anything in here other than accounts? I don't think so. Let's see, account list to UTXO. Alright, I'm almost done with this and then I'll get back to that. Account list to UTXOs. Okay, that gives us account coins. Okay, so accounts. Okay. There we go. So now I have good account selection. Okay, so let's say that I just want to take a look at my coins. And this is not the best because it truncates the value. Do I have something to inspect this more specifically? Let's see. Contact account coins. Let's see. We've got accounts. I think I can do this. I think if I take this one and I do stat on it, it'll find it. There we go. Okay, so I can go in here and I can plug this in, and then see it shows me here's the transactions that these were part of. Now, in this one in particular, this is actually an unusual transaction because it was a test transaction I was doing. Let me see if I can find one that's a little bit more usual. Probably none of these are going to be particularly usual. Maybe this John Doe one, but these are all test transactions that I did. But let's see if we can find one that's the normal style. Okay, that one's kind of... What? That doesn't make sense. Oh yeah, it does. Alright, got it. Okay, so we can look back at this transaction. We can look back at this address. Then we can look... here we go. So this is the normal way of things. This is who you were paying, and this is what you got back as change. So this paid out to there, and then this was sent back as change. And if we want to see this one, you can see the same thing. So, this one... Yeah, so this one goes back here. So then here's where that it paid out there, and that's what came back as change. And then here we can see here's what was paid out there, and there's what came back as change. And so on and so forth. So we can trace through, and we can see the nature of the payment. So notice, these are whole numbers, so this means that it probably was not being done on an exchange, but rather was being done individual to individual or as a test. And then, we can just keep going back. And then you can tell the mined date is the date which the block... no, let's see. Is this the mined date? I think that this is the date of the block, not the date that the coin was mined, because this is the same coin. It's just going through. Okay, so here we go. This one, I think this was actually a payment. Yeah, okay. So this one, interesting. Right, and then the last one here, this is the change. So we can see these are all the payments that were made. So this is probably the point at which I received that money. So I probably received that money. I see a lot of 2 payouts. Which one was this? This was a 2- payout. Okay, so I probably received this for being part of one of the Dash podcasts or something. No, this is February 21st. Yeah, so this is probably something that I received for being part of the podcast. We could actually probably do a search on these and find them on the Trello board of the task that they were attached to for payment. And then you can see the very last one is always the one that is the change, the return address. And so you can look at this, and I could look and see, and I could take a look at others of these, and I could maybe determine which payment is to whom or whatnot. But you can see these are all round numbers. This one's not a round number. So there's a lot of information here in this, and this would be a lot better if it were actually broken down into smaller chunks, so that it wasn't so obvious, who the party is. So we could follow this back, and let's see. Now this one, this is a little more interesting because it has a number of different transactions that it is appearing to be part of. Is this the same coin over and over again? This might be the same address. If this is, hold on, let me go back here. This one didn't have a big scroll on it, did it? No, not a big scroll at all. All right, so let's go back again. So what this tells us, and you can see the types of amounts that are coming out of here. There's a bunch of payment amounts. So this might be the Dash Incubator organizational address. That's my guess. But, you know, this one's not a really great tool. It's not really pretty. This one, you know, you'd be doing all of the manual labor. But this address right here has got quite a bit of Dash on it. A lot of the Dash is going back and forth. It's going out in, you know, particular amounts. So this tells a story of what's going on with this money. And if someone were to, you know, if there were a bad actor that were to look at this information and try to start analyzing the patterns of what's happening, they would probably be pretty successful in determining relationships. Just if you were to look at these payouts and then check cadences in terms of when the money moves, the secondary time, yeah, there's probably a lot that you could tell by analyzing a few thousand of these. And then imagine if you were to throw some sort of machine learning algorithm at it. Of course, you'd have to have good training data, which I don't know how much good training data there is out there, but you'd need to have some good training data. But I imagine that you know, just basically machine learning just means that you're letting a computer run a lot of permutations in a kind of a brute force fashion over and over again and finding statistical patterns of things. You know, statistical patterns could be to do with the date, the time of day, the amount, the difference in time between when it's received and when it's spent, so on and so forth. So you could probably, through forensic analysis, determine pretty easily who the different people are. And what I'm doing probably wouldn't help that much with that, because there's people's cadences are going to speak a lot about them. But yeah. Anyway. Can you get something that links between people and wallet IDs? Not really, but there is no such thing as a wallet ID. There's just payment addresses. But what you can do is you can look at payments that are going out and change that's coming back, and then you can tell from that what the relationships are. So once you have identified a particular transaction, you can go backwards from that transaction and see all other related transactions, and through the side channel information determine more information about your target. And that's just not very cache-like. And it's kind of weird. So, there we go. Anyway, I am coming up on time. I was hoping to get a little bit more done. What is this? We are the robots? This is kind of funny. I'm going to show this. I got the little Michael Jackson dancer as a robot. Or the baby bobblehead. The desktop dancer. These were so popular back in the late 90s. Gosh. It reminds me, I spent so many hours reinstalling my sound card software because it had cool screensavers and stuff. Man, that was so weird. Glad that I turned out alright as an adult. Okay. Okay. I can't. It doesn't. First of all, it doesn't look cool me doing it in the chair, and it definitely doesn't look cool me trying to do it in a way that's visible to the camera. It just. I can't dance on like this for you. Sorry. All right. Account lists. Okay, so let me at least get this piece done. Get this account list bit implemented. This is something that I've wanted to implement for a long time, so this is very convenient to get it implemented now. Okay. So account coins, select coins, and get the selection. Yeah, okay, so then we go over here to select coins. Bum bum. Bum 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 bum. I have to make noise. Because if I don't... Well... So, OC Remix is streamer-friendly music. Explicitly so. But... as is often the case... that doesn't matter. I get copyright claims on the streamer-friendly music anyway. And then, so basically my options are two things. I can waste my time appealing the copyright claim by copying and pasting the link to the OC Remix copyright, or I can just ignore it. And about half the time I just ignore it because it's not worth it. It's not like I'm literally getting dozens of views on these videos. You know, it's dozens. But it's just kind of a principle thing. I don't like it when people make a copyright claim on music that is streamer-friendly music. Especially when they're hoax claims. Because there have been a few where, okay, if it was Nintendo of America record label, that would be one thing. Or, you know, Sony, or because... okay, no, this isn't the exact rendition of the game music, but it sounds similar. And so that would be annoying. It would probably get them a lot of bad press, which is probably why they don't do it. But it would be understandable because they do have a claim on some way, shape, or form portion of the copyright. But what's really annoying is when it's fraud accounts claiming the copyright. When it's a person who is banging out the rhythm with spoons. Okay, that hasn't actually happened to me, but there's one where the guy is basically playing the Smash Bros. Soundtrack and then singing Portuguese on top of it. And I got a copyright claim from him. What? No, like it's not even his music. Okay, so we've got account coins, and account coins is okay. If I don't have UTXOs, then I'm going to use account coins. This is fine. All right, so I'm going to parse out the send values. This is where I left off. I think, do I need to do this here? And then I think I had this in the test. So I did parse send info. I forget where in the test. Okay. There's a lot of good music in the... Let me just go ahead and throw this link out. This is the strings tag. So it's things that are tagged as having stringing instruments, I guess. And I'm liking it. It's really nice. Okay, send info. Parse send info. Okay, let's see what I did with the cache like select. Cache like select. Oops. Okay, we don't have to worry about that. Input infos. Why is this not right? Okay, this is not quite right. Let me go back and take a look at the test. Send info. Okay. Alright, what does it complain about? Okay. Okay, so what do I need to do here? So we would not just parse coin info, but okay, so I think I just need another function that's basically denominate UTXOs. All right, let me think about what my problem is that I'm trying to solve here. So this one, I'm trying to select the values that will go out. Alright, it is about my pumpkin time. Being 3:40 a.m. I want to just get this last little bit solved, but my brain's a little fuzzy right now. Because we're pretty daggone close to it. Okay, parse UTXOs, denominate coins, parse send info, cache like select. But I don't need all of this. I just need UTXO infos. And then with the output info, cache like select. These denom info A's were literally for each coin. So UTXO of UTXOs. Okay, is there a reason that I do it that way? Why are we looking at the coins individually here? Because we're not sending all of the coins, we're selecting the coins. That's why. Okay, so this actually does need to be okay, and that's not where we throw an error. Alright. Skipping ahead, I don't like this piece as much. Crap. The brain drain's happening. Oh, whoops. I actually... Okay. Considering each UTXO individually rather than collectively, because we need to okay. Okay, so now if I want to say we're going to send oh, this was supposed to be remove option. Or Wallet data counts is not a function. Connect. Let's try concat instead. $11.69. Oh, did I pass null into select coins or something? Let's see, where did that stem from? 1169 and then what? 996? Let's try 996. Okay, what else? Then that. Cannot accumulate. Should be, rather than total, that should be requested. There we go, that's great. Nice. Cool. Oh, that'd be really tough to get that. All right, so now the next step, I think, is actually just to make the transaction itself. So I think we have arrived at when dry run. Dry run next time. Because this, now we have, and we still will have to go back and decide how to handle the case of a single send address or an exact send amount. And this one looks pretty good too. An improvement to this would be that when, well, let's see. I don't know. And if I don't put the accounts, all right, I get about the same value. Okay, cool. So very, very close now. Okay, so the one thing that I would like to do is if we could get the, there's another cache like select. If I could just get the input infos, output infos, change infos. Oh. Okay, I need to get these in the same format of thing. A little type info might help here. Denom info. And then we probably need to tag these. So one other piece of information is if we want to aggregate out to multiple people, because the more we can do in a transaction, the better. So if we can send, lots of people, the better off we are. Okay. Go a little further. Even though we're past my pumpkin time. Okay, output values. Can I change this into denom info? Okay. Okay. Alright, where's this denom info coming from? Is this based on inputs? Okay. Let me go look back at TSC template doc. if this actually... Trying to remember how this is done. Oh, what did I do? T. Just need to get a different error message out of this so I know where I'm at. Okay, good. So let's take a look at the difference between what these look like. So these inputs look correct. They have lots of information on them. That's good. The change has plenty of information on it. The output only has the denoms. That's fine. Now let's switch this back up to where we had specific things we were sending. Okay. These inputs still look good. I need to compare the output. Let's compare what the output looks like here. So let's run this one again. And let's compare what the output looks like here versus here. Satoshi's face value stamps per coin. Satoshi's face value stamps per coin. And then we're looking at 1, 2, 3, 4, 5, 6 values. That makes sense. Okay, so... So we just have a little bit of a swappy doodle here. Okay, but this looks good. This looks like I'm getting the right information in the right format. And we could do a little bit of massaging. To split the difference. Okay. Yeah, so the weird part is, so I wonder if denoms, maybe that should be renamed output denoms or something, and then change denoms. Because essentially we have the outputs are a little more loosey-goosey. We need to know that in aggregate they can be made. Okay, I'm going to make the decision to save this for later. So that we want to be able to output to multiple people at a time. But that is going to change this logic a bit. And I'm trying to think of how severe that change is. It shouldn't be too much. Essentially, I think with our send vowels, the way that they are presently, there needs to be a way to tag them and carry that tagging information through. Because essentially I need to be able to say, okay, my total... Yeah, I think what this needs to be is actually at another layer. So I need to be able to say, okay, my total outputs to all parties is X amount as a face value. And then I need to be able to get back... Yeah, I need to be able to say it's X amount, and then I need to be able to say how I expect it to be denominated. So I can pre-denominate it as an output value, pass that in, because I've already got support for that with the send vowels. So pass that in, and everything should still work. And then when I get the outputs, then I would just do the sorting as to which specific output goes to which specific person later. Because at that point, I'm guaranteed that I have the matching set that I need. So that's good. Yeah, that shouldn't be a problem. That should just be a layering thing. As long as I can specify the denoms that I want to pass through to receive back, then all the calculations remain the same. Okay, cool. So the next exciting episode of Dash Incubator Live Code will be when we do the dry run for real, because now we have implemented what we needed to implement. And then the way that so a number of these problems we're going to solve with layering. The problem of not having the correct amount of change. So if we need to send to a single output, the way that we'll do that is we'll break the change first. If we don't have exact change, then we'll make the selection, we'll send the outputs, and then we'll make the selection and send just the part that we needed. And this will work out great with the way that instant send works, because both of them will make it into the same transaction. So we'll be able to spend it and spend it again while it's still waiting. Okay, this actually, though, was very painful to get to this point. I think it might have turned out better than I had anticipated, and at least in some respects. So maybe the change... kind of thinking that maybe the change should actually be at another layer. So we should just have inputs and output. And the difference between... Yeah, so we just go through a second time of the output. So once we get the output, we'd go through the denoms a second time, and then we should be able to pair up the denoms. So basically, at that point, we're guaranteed a perfect match. We're guaranteed these denominated outputs will perfectly match the requested face values. Yeah, okay, I think that's going to work. All right, I'm going to go ahead and just whip commit these. So we're very, very close. Like I said, next time I'm pretty highly confident that the next time will be the real dry run. Because we're at the point where the only... We can go ahead and get out the dry run, and then we can add in a little bit of additional layering. We need a little bit of additional layering for change, but the same layering that will be for change will be the same layering that will be for multiple contacts or sending multiple payments, is that we can pre-denominate face values and have those sent through the whole way. And again, we kind of have two calculations going on, because there's the calculation of what do I need as inputs in order to put this out, and then there's the calculation of what outputs do I want, because outputs are much lower cost than inputs. So maybe if we might want to increase the min stamp value from 2 to 3. Just to account for possible extra outputs. But it'd kind of be during the selection process, we'd want the minimum to be 3, but then in the output process, the minimum could go back down to 2. That should work out just fine. Okay, anyway, yeah. I'll go ahead. Nice. I've got account selection now too. This is great. All right. Well, looks like I'm going to go hit the sack. Thanks for tuning in. Appreciated the conversation, especially Quant Karen. That was nice. And y'all have a good one. I'll catch you later. Good night. And oh wait, you know we need a little fanfare though. All right. Good night and adios.